All right, guys, let's do this review for test 16, first test of second semester. First of all the formulas written on the top that you'll need, so make sure you see those up there, and we'll be making use of those. Number one, don't need any formulas for this one. Find the first four terms, then find the 9th term and the 12th term. So the first four terms, you plug in 1, then 2, then 3. So A1, I'm plugging in 1 right here. 5 times 1 is 5, plus 1 is 6. A2, I'm going to plug in 2. 5 times 2 is 10, plus 1 is 11. A3, the third term, 5 times 3 is 15, plus 1 is 16. A4, 5 times 4 is 20, plus 1 is 21. Notice there's a pattern there, it's increasing by 5. The 9th term, plug in 9. 5 times 9 is 45, plus 1 is 46. And the 12th term, 5 times 12 is 60, plus 1 is 61. Same thing for number 2. It says find a 6. So all I'm going to do to find the 6th term is I'm going to plug in a 6 right there and a 6 right there. And then work that out. 3 times 6 is 18 minus 5, that's 13 there. That's going to be 29. And everybody knows 13 times 29. I'm just being sarcastic. I'm actually punching it right now. Is 377. And there's the 6th term. Number 3, find the partial sum. So sum of the first 8 terms. Now let me see how many we got here. We've got 1, 2, 3, 4, 5, 6. The next term would be 20, then negative 23. My job is to add all those together. I'm going to take 2 at a time. If I take those 2, that's negative 3. 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 And then I have that negative 23 at the end. So negative 3, that's negative 12, and negative 23, that's negative 35 when I add all those up. You can also just punch all those straight in your calculator, obviously. Number 4, a sigma. Got to plug these numbers in, remember. So you start off with sigma by plugging the 1 in. 1 times 2 is 2. Plug 2 in. 2 times 2 is 4. Plug 3 in. Plug 4 in. Plug 5 in. And plug 6 in. The reason I stop at 6 is because 6 is the number on the top of my sigma. I'm going to take a second, punch all these in my calculator. Before I do that, I don't know if this helps you or not, you can punch those straight in like you see them. If you know the decimal, like you know 1/2 is 0.5, you know that's 0.25. Don't really know 1/6. 1/8 is 0.125. 1/10 is 0.1. That will save you some time when you start to punch your calculator. All right, when I punch all that in, I'm getting 49/40. I really like to have your answers of fraction right there, even tomorrow. Number 5, find the first 4 terms of the recursive sequence. Recursive means you got to have the previous one to get the next one. So when you see, oh, by the way, I didn't tell what A1 is. Let's say A1 is 1. All right, so sorry about that. So A1 is 1. This is saying the next term is 1 plus 1 over A. Well, let's do this. A1 is 1. That's the first term. Second term, I'm plugging to get the second term, I have to plug a 1 in where that n is. So it'd be like A is 1 plus 1, which is A2, which means everywhere there's an n, it's a 1. And we already know A1 is 1, so that's going to be 2. Really what we're doing here is I'm doing, when I start working this out, I'm doing 1 plus 1 over the previous term. The previous term was 2. 1 plus 1/2 was 1.5, which is really 3/2. And to find the 4th term, the last one I got to do, I'm doing 1 plus 1 over the previous term, which is 3/2. Anytime you put 1 over anything, it's really the reciprocal of what's on the bottom, which gives me 1 2/3. 1 2/3 is really 5/3. And there you have it. There's the first 4 of a recursive. Number 6, first term and difference of arithmetic. Right, the first term is 5. Difference is 6. You're not even allowed to miss that one. 16th term of an arithmetic, I'm going to do A16. I'm using the formula. It's the first term plus n minus 1 times d. N is 16. 16 minus 1 is 15 times d. This time d is negative 4. I'm just going to punch that in. Looks like I'm getting negative 51 right there. Number 8, 110. Now it's going backwards. 110 is what term in this sequence right there? Okay, so that means 110 is the last term. So I'm putting it over here. The first term is 2. N minus 1. I'm trying to figure out the n. I know d is 4. N means what term it is. So that's why I'm looking for the n. It's asking me what term is it? That's n. That's what n always is, what term. So move the 2 over. That's going to be 108 equals n minus 1 times 4. If I divide both sides by 4, I get n minus 1 equals 27. Move the 1 over, I get 28. So it would be 110 would be the 28th term of that one. Number 9, find the sum. Now I'm using the sum formula. Okay, so I'm doing the sum of the first 18. So we'll do 18 over 2. The first term is 5. Now here's the problem. I don't know what the 18th term is. Okay, and if you don't know something in that formula, you go back and do the original formula. So I'm going to need the 18th term. The 18th term is the first term plus n minus 1, which is 17, times d. D is 3. 17 times 3 is 51. 51 and 5 is 56. So it gives me 9 out here, 61 in there. 9 times 61 is 549. There's number 9. Number 10, find the sum of the first 100 natural numbers. Natural numbers are counting numbers. You're going 1 plus 2 plus 3 plus all the way to the 100th one, whatever that is. Well, it'd be 100. So, sum of the first 100. There are 100 terms. So I'm going to do 100 divided by 2. It's arithmetic because the difference is the same. I'm going to do the first term plus the last term. Just following the formula. 100 divided by 2 is 50. That's 101. Everybody knows 50 times 101 is 50, 50. There you go. So if you add up the first 100 numbers, you get that. Number 11 is sigma again. Now, this one's arithmetic, and I can tell that by, like, if I plug in 1 right there, I hope it's arithmetic because there's 40 terms. If I plug in 1, I'm going to get 4. If I plug in 2, I'm going to get 7. If I plug in 3, I'm going to get 10. So you see what's happening. It's definitely arithmetic. So the good news is with sigma, you only need the one formula. So the n is always the top minus the bottom plus 1. Top minus the bottom plus 1. So 40 minus 1 is 39, plus 1 is 40. So I'm doing sum of the first 40. The first term goes first, that's 4. Then I need the 40th term. The way you get the 40th term is you plug the 40 in there. 3 times 40 is 120, plus 1 is 121. So I get 20 here, 125 there. Just take that 20 times 125, and you get 2,500. So if you add up the first 40 terms of that sequence, you get 2,500. Number 12, now we're starting geometric. What's the common ratio? Remember how to find R. R is always the second number over the first number. So if I were to do negative 5 over 25, I would get negative 1/5. That's the R. Number 13, find the 8th term of the geometric. Just going to use the formula for geometric. Okay, the 8th term would be the first term times R. R is negative 4 to the n minus 1 power. So it would be the 7th power. So I can punch that in. 3 times negative 4 to the 7th power. I think that's 7. I'm getting negative 49,152. Pretty big number, but it's geometric. They grow really fast. 14 says find the nth term, which means you're looking for the pattern here. And if it's geometric, you just write the formula. So the nth term is the first term times R. R is 4 divided by negative 2, which is negative 2, to the n minus 1 power. And because you're looking for the nth term, you leave the n's in. Remember to leave the n's in there. 15, find the sum of the first 12 of that geometric. So I'm using the big formula for geometric. I'm going, sum of the first 12 is going to be the first term, which is 6, times 1 minus R. R is 2, to the nth power, which is 12, over 1 minus R, which is 1 minus 2. And again, the way you find R, first number over last number. Sorry, second number over first number. Now the bottom of that one is just negative 1. I know it's going to be over negative 1, so I'm not going to punch that in. I'm going to punch in the top. 6 times 1 minus 2 to the 12th. One piece of advice here, even though I didn't have to do it this time. If it's a negative number for your R, this 2 right here needs to be in a parentheses. So does that one. But because it's positive, it didn't really matter that much. I'm getting negative 24,570. When I punch, you may want to punch it and make sure you get the same thing. If you divide that by negative 1, obviously it becomes positive. And there you have it. 16 is sigma. Sigma is easy because you have everything you need. This is geometric because it's got that exponent. So I'm going to do sum of. Now remember, what's n? N is top minus bottom plus 1. 50 minus 0 is 50. Plus 1 is 51. So there's 51 terms. So I'm doing the first term. The way you get the first term is you plug in that 0 right there. Anything to the 0 power is 1. So it's going to be 200 times 1, which is 200. R, that's going to be your R all the time. Every time you see a geometric with a sigma, whatever has the exponent is the R. So it's 1.08. And I need n minus 1. My n is 51. 51 minus 1 is 50. That's a long setup. Be careful. It's not hard. Just kind of think your way through it right there. to the 50th. I'm punching it in as I'm talking, and I'm getting 9,380.32. It really goes further than that, but 2 decimal places is good enough. Let me see if I'll change it to a fraction. I doubt it. No. Okay. 17, find the sum if it exists, hint, hint. If it exists, this is ... which means it's infinite, goes forever. You need to find r first every time. This time r is 2, because 12 over 6 is 2. And remember, if r is bigger than... r has to be between -1 and +1, or you can't do it. So this one, DNE, it does not exist because r is too big. On this last one, though, down here, r is 3/7, second over first, which means it does exist. So the formula for the for infinite is the first term over 1 minus r. So I'm going to do the first term, which is 7, over 1 minus 3/7. You can punch it in just like that if you want to. I'm going to do it by hand. 1 minus 3/7 is 4/7. Fractions, you do keep, change, flip, like that. So you get 49 over 4 when you're done. First sum. Guys, that's it. No review this week because we have nothing to review. It's a brand new start. So hope that helps. Get off. It's very important to get off to a good start every single semester. So get off to a good start. All right. See you tomorrow.